Hello, we are getting into modeling a solitaire game. Now, I have to remind you that this is an exploration of the different ways that we could model solitaire. I'm not going to say the right way because I don't think there is a right way that works for every situation. What I am going to do is try to give you a lot of tools that you can keep in your toolbox and use when you need them. And we'll talk about the trade-offs of the different representations as we get to them. So we're going to start with modeling the cards because the cards are the smallest unit that we deal with. And in fact, there's a choice we have to make before we decide on how to model the card. It's how do we model the suit and the value. Those are the two components of the card. And my inclination is to use a keyword. So we would do diamonds, clubs, spades, or hearts. You could use a string, you could use numbers, but it is generally regarded in the Clojure world that when you have a simple named value like that, you just use a keyword. So I'll just leave that like that. Now the value becomes a little bit more difficult. The value, some of them are numbers and some of them are letters. Now you could represent an ace as a 1 and then do all the numbers up to 10, and then you could say that the jack is 11, queen is 12, and the king is 13. That would be okay. It might get confusing when you're reading the code. You might forget what a queen is. Is that an 11 or a 12? I can't remember. Another way we could do it is to spell out ace, and then jack, queen, king. One thing I notice is that the values that aren't numbers are representable as a letter, which is what usually happens on the card itself when they print the card. So we could do A. And I'm going over all of these different options because they are all valid. The values will make it very easy to compare which one is greater than, which one is lesser than. So when the A is less than the 2, you would really have to program that in. So this representation does have advantages. This one has advantages too, in that the cards look like what they in the code, they will look like what you would imagine they look like on a real card. And then there's another option, which we could just say, well, they're all just characters. So why not just, I just want to make sure that you can make a keyword with a number. That's not easy to remember. You could do all of these like this. And that way you're not dealing with two different types mixed together. And the number, we're going to have to convert the values anyway. If we were using this representation, we would have to go through some function that like converted an A to a 1 or a J to an 11. So this way you're dealing with a single type, and this one I think that's the one I'm gonna choose when we move forward. Okay, so we know how to represent a suit, we know how to represent a value. Now when I'm choosing this, I'm just choosing this because I need to choose something to move forward. All these options are valid, and they depend on what you're going to use them for, and so please make your own decisions in this case. Okay, now we're going to get into how we represent a card itself. Now, in an object-oriented programming system, which you may be familiar with, the tendency is to make a new class called card. And the card would have two fields, the suit and the value, and maybe more. You might want to represent, for instance, where the card is on the board, inside of the class. In Clojure, the tendency, and it's a good tendency, is to think more about identity and less about state. So the state of the card we're going to represent later. Right now, we just want to know which card it is. What is the identity of the card? And the identity of the card, all cards are identified by the pair, suit, and value. So a very simple way to start is the typical way, just using a map like a record structure. So we would say suit, and then we could say clubs, and value is 3. That could be a valid way to represent it. It's very common to represent things as data structures like this. And sometimes you might want to get into another option, which is, well, I have all these maps floating around. Maybe I want to remind myself that that is a card. And so you can use that type to dispatch on in a multi-method or some other statement. That is an option. I actually don't like that, but it's very common, so you should know it. Another thing that we could do with this record, because this is what happens when you have a lot of room in your map, you can have basically unlimited keys. So you start to think, well, I could put in the color. That way I won't have to calculate it every time. This happens a lot, but notice you're introducing a problem, a potential problem that will probably happen over the course of time, which is that now the spades and the black have to be kept in sync. So what if you had spades in red? What do you do there? Do you just throw an exception? Well, why did you even include that possibility in the first place? So we want to avoid those kinds of corner cases. So I say, if you're going to do one of these 3 using the map, then the first one is the best. It's the simplest, and we haven't really demonstrated a need for having a type in there yet. So it's basically Yagni. You ain't going to need it. And the same with color. It's just introducing another problem. But we could continue down this road. You could make a record called card, and it would have a suit and a value. Now, a record acts just like a map, except it has, in this case, these 2 values, these 2 keys will be faster to access because they're baked into the class. Card will make a new class. Def record will make a new class called card. Well, if you're making new types, you might want to say def type. It's another option. And this doesn't act like a record. It doesn't act like much of anything yet, but it's an option. And in certain cases where you're going to implement a lot of protocols and you want it to be very efficient, this is a valid option. One of the difficult things with def type is that it does not define any of the methods you're used to, like equals or the hash function. Those things are not defined automatically. You have to define them yourselves. So it's not that easy to use, but sometimes you need to go there. But we're not going to go down that road. Another way to represent it is to, well, if we think this is actually a pair of a suit and a value, well, we could actually just write it like that as a vector of a suit and a value. This is a very concise representation. I like it because it's short. It's exactly what we want, and it's gonna be pretty hard to mistake that this is not a suit, right? Like in this case, we're saying, here's the suit, it's spades. In this case, we're just saying spades or clubs. And we're not saying it's the suit. But to me, that's not a legibility issue in this case because they're so distinct. If you had something like X and Y coordinates, you start to question, well, in basic math, you do use X on the left and Y on the right. Okay, that makes sense. You start getting into other pairs, maybe the order is not so clear, but they're the same type. You might want to use a map instead. There's just one more thing we could do to that vector. It's to put in a kind of type identifier there at the beginning. Just to clarify that what type it is. And so this is going that extra mile that we went up here to say, I'm not just making a list of some keywords. I'm making a list and the first thing is a keyword. And that keyword is special. The keyword represents the type. And so then you could do something later where you had some other type, like let's say hand. I don't know, I'm just making it up. And then that hand has some values in it. Like it has 6 cards in it, and it's for player 4, right? So then you wouldn't confuse these two together because of the first element of that list. So you're kind of blessing that first element, and it tells you what the other 2 elements are supposed to mean. So I'm going to start with this representation. There's a lot of different ways to represent it. They're not good for all cases. And so you're probably going to get it wrong. Like you're probably going to choose the wrong representation. And in a year or 2, when you're maintaining this, you realize it. But you've got all this code that assumes this representation or the one you chose. And now what do? You're stuck with it. So I'm going to show you in the next lesson how to make that not an issue. So you can just continue with any representation that will work, because all of these will work, and be able to change your mind later as you learn more about the actual program that you're writing. Okay, thank you.